So hopefully everybody's done their homework and you're just checking this. We need to first talk about P's and Q's. So Saturday is P, and it should be let Q be the weekend, right? So if we're going to do conditional statement, that's P, then Q. If it is Saturday, comma, then it is the weekend. Need a new stylus. And then the converse is going to be change order. So instead of PQ, it's going to be QP. So then if it is the weekend, comma, then it is Saturday. All we did was change the order. By the way, PQ is valid. This is a valid conclusion if they are separated. This is an invalid conclusion if they are separated. That converse you cannot do. And then I've got inverse. Inverse is insert not. Get a little bit red. So that's going to be back to our not P and not Q. So if it is not Saturday, then it is not the weekend. This is another invalid pattern, right? We cannot just negate things and assume they're going to be the same. However, our next pattern is a valid pattern, contrapositive. We've got to switch and negate. So we take the end and give it a not. If it is not the weekend, comma, then it is not Saturday. This is a valid pattern. So I can keep the order or I can change and negate the order. Both of those are okay. The biconditional we just touched on, that's if and only if. So we take those and it's P, if, and only if Q. So it's a lot of words, right? P, you're going to keep the order. It is Saturday. It also does not start with an if. It is Saturday. It is a statement. And then if and only if it is the weekend, right? So that if and only if has to come in the middle. If and only if has to come in the middle, okay? Piecewise function, which interval does not have a vertical line of symmetry. So we're going to do vertical lines to see if they're the same on both sides. So between -6 and -2, between -6 and -2, if I slice that in half, that's the triangle that works. If I go from -2 to 2, from -2 to 2, that's a semicircle. I can slice that in half and it works. I'm looking for which one does not have a vertical line of symmetry. What if I look from -6 to +2? -6 to +2 is that whole way. Is there any way for me to slice that in half and have the left and the right be exactly the same? I think this one does not work. So let's go ahead and test the rest of them because we might find a surprise. 2 and 7, between 2 and 7, that whole isosceles trapezoid can be divided in half vertically, so that one works. And then between 4 and 5, between 4 and 5 is this little rectangle right here that can definitely be sliced in half, so that one works. I think the only one that doesn't work is that -6 to 2. A line in the XY plane passes through the origin. So normally they would give you a picture, passes through the origin and has a slope of 1,7. So that's a rise over a run of 1,7. Which of the following points lies on the line? So I'm going to take my stylus, I'm going to just plot them. 0, 7, that's A. That's not going to be on that line. 1, 7, oh, that looks good. That's B. 7, 7, 7, 7 is not going to be on that line. That's C. And then 14. Oh, you know what I did wrong? I'm doing slope here, ladies and gentlemen. You can't do that. Let's fix that. That's crazy. This is my X and this is my Y. So 0, I don't go anywhere right and left, and I go up to 7. So that one was okay. I don't know why I'm second guessing myself. 1, 7 is right 1, up 7. That's B. That's not going to work. And then right 7, up 7, that's C. That's not going to work. 14 and 2. So 14 is going to be 7, and then another 7, and then up 2. 14 and 7 is, I think, going to be our answer. So be careful when you're plotting. Don't do what I started to do. When you figure out you've made a mistake, go back and check. What is the equation of the line with the same slope as the line below? So if we go to the intercept is x equals 4. That's the equation of our line. So we need the same slope. We want a Vux line, a vertical, undefined, x equals some kind of number line for it to be the same slope. So we need x equals 1, and that's going to be x equals 1. If you're not sure, you can always come over to Desmos. I have some other things in Desmos right now, but you can plot them all. So y equals 2, and y equals negative x, and y equals 4, y equals 4, and then x equals 1. X equals 1 is the only up and down line. It's that purple line. It's the only one that'll work. Now in for our trig. So solve the missing angle, round to the nearest whole degree. Start with my angle, and always label the O, the A, and the H. So O and H, I'm going to use sine of my angle, but I don't have an angle, so I'm going to put that -1 inverse, and then O over A, 23 over 24. You're going to come over here to your Desmo, get rid of those equations you just put in there. Remember, you need to have it in degree mode. Mine's already in degree mode. Come over to functions. We're going to do inverse sine, and then 23 divided by 24. Looking for that angle. So that angle is 73.4. Round to the nearest whole degree. Round to the nearest whole degree. Solve for the missing angle. So same thing. We're going to do O. This time we've got A. SOHCAHTOA. SOHCAHTOA. I've got O and A, which means I need tangent. Tangent of my degree, but I don't have a degree, so I put in that placeholder, that -1, and then O over A. So O over A, 10 over 13. Come over my handy dandy Desmo. Find in the functions key inverse tangent, and then 10 divided by, 13. 37.6. 37.6, and then round to the nearest whole degree. Got to make sure you can round to the nearest whole degree. Solve for the missing angle, round to the nearest whole degree. It's getting kind of tiresome. So I've got the O, I've got the H, and I've got the A. I don't have anything on the O, so I can't do sine, and I can't use tangent. Got to use cosine. Cosine of my angle, I'm looking for my angle, so I do the -1, and then 9/17. Feel free to pause me, do it yourself, come back, make sure you know how to do it. Like, this is not me doing the work for you. This is you checking your work after you've already done it. So 9 divided by 17, and that's going to give me 58. 58. Okay. Scott is using a 12-foot ramp to load furniture into the back of a truck. So I draw my cute little truck. And we've got a ramp and the ground and the height of the ramp. So the back of the truck is 3.5 feet above the ground. What is the horizontal distance? That's my question mark. Horizontal distance is horizon, left and right, where the ramp reaches the ground to the truck. Scott has a 12-foot ramp. That's the length of the ramp. So ladies and gentlemen, what are we going to do here? We're going to use sine, cosine, tangent, inverse sine, inverse cotangent, inverse, whichever one I missed, cosine, or we're going to use Pythagorean theorem. We're given two sides and we're looking for another side, so we need to use Pythagorean theorem. A squared plus B squared equals C squared. Remember, your A and your B are your legs, and your C is always the hypotenuse. So 3.5 squared plus B squared equals 12 squared. When you have a hypotenuse and you're looking for a leg, you're going to end up subtracting. So over in the calculator, you're going to do 12 squared minus 3.5 squared, and then take the square root of that. Square root 131.75. It's going to be 11.48. And this says round to the nearest tenth. So 11.5. 11.5. Okay. Jake leaned a ladder against his house. So we've got a house. We've got a ladder leaning up against it. Probably a lot of you did this, putting up holiday lights. The ladder is 12 feet. The angle formed by the ladder and the ground. So where does the ladder meet the ground? The ladder meets the ground down here. That's 68 degrees. How far from the base of the house did he place the ladder? How far from the base of the house? I want to know this distance along the ground. So this is going to be A and H. So that's cosine of 68 equals x over 12. I can always make that over 1 and then cross multiply. So cosine of 68 times 12. I like to do the 12 first. Make fewer mistakes that way. And then cosine 68. And you can close those parentheses if you want. And that's going to be 4.5. 4.5 feet. Okay. Last question. A nursery plants a new tree and attaches a guy wire. That's not a dude. That's this guy wire right here to support the tree. That's what that's called. While the roots take hold, an 8-foot wire, so that's my 8 feet. I had to blow it up because I couldn't see it. 8-foot guy wire is attached to the tree and staked to the ground. From the stake in the ground, the angle of elevation. So from the stake in the ground, the angle of elevation is 42 degrees. Find to the nearest tenth of a foot the height of the connection point of the tree. So we're looking for X. We've got O, we've got H. O and H is sine. So sine of 42 equals O over H. I can put my 1. Now we're going to cross multiply. Sine 42 times 8, or 8 times the sine of 42. 5.35. And does it say find to the nearest tenth of a foot? Find to the nearest tenth of a foot. So that's going to be 5.4. 5.4 feet. Okay, that's it, guys. I hope you had a great lesson and you're not too stressed out about inverse trig. I'll see you on Friday.